You're welcome back to my channel. In my previous episode, we take a look at the two physical quantities, which is the fundamental and the derived. Today, we are going to be learning scalar and vector quantities. These are other kinds of quantities. That means description of quantities based on magnitude, which is the size, and also the direction of the quantity. If you are new to my channel, please don't forget to click on the subscribe button and the like button to subscribe and like my video. Let's get started. As you can see that there are varieties of quantities in physics. Among these quantities, some of them are scalar. That means quantities that depends only on size and it is independent of direction. That is what we call scalar quantities. Now, while some of them are vectors, vector quantities are the quantities that depends on direction and magnitude. That means these quantities can be described fully with direction and magnitude. Now, all fundamental quantities are scalar in nature. Please, if you have not watched my video on fundamental quantities and units, you can click on the description. You can click on the link in the description box below to watch the video so that you can have a great understanding of this. Now, as I'm saying, I said most all the fundamental quantities that we have, the seven fundamental quantities that we have are all scalar. That means we can only describe them with size, that means magnitude. While few among the derived quantities are scalar, the rest are derived. How do we know the ones that are scalar among the derived quantities? As I've already given you for what's fundamental. The scalar among the derived quantities are given. Examples of scalar that are derived quantity. Number one, we have speed. Number one, we have distance. That's number two. We have pressure. Pressure is a derived quantity, but it is a scalar quantity. We also have energy and its family. Energy and its family. A lot of students get confused, but when I'm referring to, in this case, that energy and its family, I'm referring to everything that can be measured in the units of energy. Yes, they are all described as energy and its family. Take a look at this. Energy is related to work done. Work done. Energy is measured in joule. Work done is also measured in joule. Now, also, we knew that we have different kinds of energy. We know we have the kinetic energy and the potential energy. The kinetic energy is the energy due to motion of the body, while the potential energy is the energy due to virtue of its position. That is potential energy. You now see these two, Ke and Pe. These Pe are classified based on the field where we need it. For example, we might have elastic potential energy. Elastic potential. This elastic potential energy. Elastic potential energy, which is, let me abbreviate as PE. Elastic potential energy. This is the energy possessed by a spring, or let's say a rubber. Yeah, an elastic spring. The energy that is possessed by an elastic spring is known as elastic potential energy. We also have electric potential energy, electric PE, electric potential energy, and the gravitational potential energy. Gravitational potential energy. We also have the magnetic potential energy. You see, all these are all kinds of potential energy. They are all known as families of energy. So energy and its families are all scalar in nature. In case you see this in your option, which of the following are scalar quantities? They are not putting for you electric PE, electric potential energy. Please note that they are scalar quantities. Please, don't get confused about that. Kinetic energy is also what? Scalar quantities. Now, we can also have power. Power can also be related to them. So I can classify power as also the family of energy. Because power is the work done per time taken. Yes, that is our power. Now, that is for scalar quantities. What about derived quantities? As I said earlier, I said derived quantities are quantities that are formed from the combination of two or more fundamental quantities. Yes. But what I want to refer to is vector. I said vector quantities are quantities that can be described with both magnitude and direction. We can describe them by the magnitude, which is the size, and the direction to know where they are going. Are we together? Now, some of the derived quantities that we have are vector quantities. For example, these are the ones that they test your knowledge on in JAM. Now, we have examples of vectors. We have the velocity and its family. When I refer to velocity and its family, I'm referring to all quantities that are related to motion. What are the quantities related to motion? Velocity, acceleration, displacement and force. Now, these quantities are related to motion, momentum, and impulse. All these are related to motion. They are all vector quantities. Now, everything that are related to field intensity are also a vector quantity. Now, what are the things related to field intensity? We have three types of field. What is field itself? A field is a region of space where some physical quantities can be experienced. That means we can experience some forces. Now, there are three different kinds of field. We have the gravitational field, the magnetic field, and the electric field. So all these fields are all vectors. The field, magnetic field, gravitational field, magnetic, gravitation, and electric field. Now, each of these fields, they create lines of forces. We can have electric lines of force, which is created by electric field. We can have gravitational lines of force. This field, they create what? Lines of force. That is what they use to exert force on each other. Now, we have gravitational lines of force, magnetic lines of forces. Now, each of these lines of force, we call it flux. Now, please note, magnetic flux, in case of you are seeing this kind in your example, which of the following is a vector quantity? You now saw magnetic flux. Magnetic flux is generated by magnetic field. So, magnetic flux is a force. And we said force is a vector quantity. Automatically, magnetic flux is a vector quantity. Please take note of this. So, if you have magnetic flux, electric flux, they are all vector quantities. Also, we can also have magnetic induction. Now, magnetic induction is also a vector quantity. This question has been asked some years back in JAM. They gave them the option. So whenever they have to ask a question on scalar and vector, they major on these examples. Now, other examples, I think I've given you most of the examples that are there that are vectors. Please Density is also a scalar. Your volume, they are scalar. Area, they are all scalar quantities. Please note all this. And don't forget. Take your book. Write there examples of scalar, examples of vector, then jot it down. For your next jam, you can really understand this. I think this is quite helpful. Thank you for watching this video. Please support my channel by clicking on the subscribe button and the like button to subscribe and like my video. See you in my next episode. Thank you.